So welcome to the last chapter of AP Precalculus, and that's 3A and 3B. So we do 3.1. It's all about periodic phenomena. So I'd like you to write down as input values increase, the output values demonstrate a repeating pattern over successive equal length intervals. We have what is called as periodic. Okay, so can you write down periodic? Okay, so periodic relationship. Another word to describe this would be cyclical or every cycle. Now look at this one, guys. The cycle for this one. Now, this is a graph of sine function. Now, the cycle starts here. Then one cycle for sine is here up to here. Okay, that's one cycle. And let us have this until here as one period. Okay, one period or one cycle. Okay, one cycle. So we have period. So what is period again? It's gonna be the cycle. So it starts right here, and then so this is 90 degrees, 180 degrees, 270 degrees, and then back to 0 or 2 pi or 360 degrees. Is this clear? Okay, so if we have the graph of a single period or single cycle, then we can construct the graph of the periodic relationship. The following graphs show one period of a periodic function. Okay. So, example number 1, sketch the rest of the graph of on the given axis. Now, this is the complete cycle, guys, or period. Okay. Now, right here, at the value of x2, it's going to be 90 degrees. And then at 4 is 180 degrees. And then at 6 is 270 degrees. And then at the value of x8 is equal to 2 pi or 360 degrees. So this is one period, okay, or one cycle. Now, let's take a look on the period. Now, if I'm gonna extend this graph, the graph looks this way. Okay, and then this goes this way, and then so that's the cycle. So the cycle is repeated all the time. Okay, so it is repeated all the time. Now, I'd like you to look at this one. It starts at 1. And where do the cycle ends? It ends right here. Okay? So therefore, we can say that the period is 8. 1, 2, 3, 4, 5, 6, 7, 8. To complete the cycle, we have 8 periods. Again, to complete the cycle, we have 8 periods. So we have period 8. Okay, how about this one? If you're gonna extend, so the next cycle, this is the first cycle, right? How many periods is this cycle? How many period is this cycle? 4, right? Starts right here and then ends right here. So we have period is 4. So the cycle, another cycle, and it goes this one, this way, and that way on this side. And if you're gonna continue also on the left side, so you draw. Is this clear, guys? So how many periods? 4 to complete one cycle. Okay? Now, is this clear? Now, if you have highlighter, guys, I need you to highlight the period of the function is the smallest change in x values for the function to repeat itself. So, the period of the function is the smallest change in x values it takes for the function to repeat itself. So, that means, let's go back to number 1. So the cycle is how many periods? 8. So for every cycle corresponds 8 period. You get me? So what do you think is the second cycle? It will be until 16. The third cycle would be on the 24th. The fourth cycle on the 32nd, right? 32nd. Okay. How about the second one? The period is 4 for every cycle. So 4. The next cycle would be at 8. The next cycle would be 12. The next cycle would be 16. So that's the cycle. So the period of the function is the smallest change in x values it takes for the function to repeat itself. In fancy math terms, we say the period of the function is the smallest positive value of k, such that we have f of x plus k. So we have f of x plus k is equal to f of x for all x in the domain. So let's move on to number 3. Number 3 and number 4 says identify the length of the period. We're going to identify the length of the period. So again, what is the length of this period? 8, right? The length is 8. How about this one? It's going to be 4. So let's move on to number 3. Okay, given right here that the period is from 1/4 up to 3/4. So this is the given period. A given cycle rather. Starting 1/4 and it ends at 3/4. So remember, our upper limit is 3/4 and the lower limit is 1/4. Therefore, we do f of b minus f of a, right? So, which means the period is 3/4 minus 1/4. So, common denominator is 4. So we have 4. And then we subtract now 3 minus 1. What is 3 minus 1? 2. So we have the period is 2/4, or what is the period? 1/2. The period is 1/2. So the period is 1/2. Okay. Next, moving on to number 4. Now look at this graph, guys. Starts here at -4. And where do the graph ends? The complete cycle. It ends right here. So what's the period? F of B minus F of A. What is F of B? 12. Right? And then what is F of A? -4. So 12 minus -4. So therefore we have 12 plus 4, which means the period is 16. So from -4 all the way to positive 12, the period is 16. Okay? Any question? Okay, so let's move on to the next one. Hi Mario. Thank you. So periodic functions take on various characteristics. What are these characteristics of the function? It's going to be increasing. Next is it could be decreasing, or we have concavity, either concave up or concave down. And if we have concave up and concave down, we're going to have to do also relative minimum and relative maximum. Again, guys, what are these characteristics? To look at the graph, whether the graph is increasing or decreasing. And then what's next? Concavity, either concave up or concave down. And what's next? The extrema, either relative minimum or relative maximum. Okay, I'd like you to imagine, or if you have time, please look at the mountain. On top of the mountain, it is the maximum right there. And if we have a valley, right there at the bottom is the minimum. So relative max on top of the mountain, and in the valley we have relative minimum. That's very important, guys, to identify this. Okay, so recognize that any characteristics found in one period of the function will be in every period of the function. Now, look at this. What is the period of the function? Look at the graph. What is the period of the function, guys? 4. So the period is 4. That means for every cycle takes 4. Right? One cycle, one period. It takes 4 units. Okay. Now, question. Is the function increasing, decreasing, or both on the interval 18 to 20? Now, one cycle. Look at this first. Please, guys, please. Close your Chromebook. I need you to listen here. Close your Chromebook. Close your Chromebook. Okay, the Chromebook doesn't help you understand. Because sometimes the author right there talks too fast. Okay, need you to listen right here. What is the period? 4. So that means this completes the cycle with 4 periods. So this is from 0 to 4. So what will be the next cycle? The next cycle, if we continue this one, so the next cycle starts 4 up to what?
8.
Up to 8. And the third cycle starts 8 up to 12. The next cycle is 12 up to 16. Okay? So that means 0 to 4, and then keep going, 4 to 8, and then 8 to 12, 12 to 16. Therefore, it is understood that the 16 is right here for the next cycle, right? So 16 to what? To where? 20. Okay, now look at this. To complete the cycle, and let's have this. From 16 all the way to 20, or 18 to 20. If this is 16, this must be the 17, and this must be the 18. You get me? So the 18 is right here. Okay, if this is 16, this is the 17, this is the 18, and this is the 19, and then 20. Okay. Is the function increasing from here, from 18 to 20? Look at the graph. Look at the graph from 18 to 20. What is the function? Increasing or decreasing?
Increasing.
It's an increasing function. So, I'd like you to write the function. This is how you justify in the actual AP exam. Comes May 13. So the function is increasing from the interval. And what's the interval? 18 to 20. This is how you justify your answer, guys. You don't have to only say increasing, but you're gonna write it this way for you to earn how many points? 3 points. Okay. Next, question B. Is the function concave up or concave down, or both, on the interval 31 to 33? So shall we continue? We stop at 20, right? We stop at 20 for that particular cycle. So the next cycle is from 20 to 24. But the question is 31 to 33. So we're gonna continue again for the cycle. We don't have to keep going because we have limited space. But test taking strategy, do it this way. And this is not found in the video. That's why I need you to listen. Okay? So, can I erase this first? Okay. So the next cycle would be 24 to 28. That means 24, 25, 26, 27, 28. Clear? So what's the next cycle, guys? 28 to 32. Okay, but this is 33, right? So therefore, we're gonna have 31. If this is 32 to 32, 33, 34, 35, 36. Okay. So we have this. Starts at 31. Where do you think is 31? 31 is right here. See me? 31 is right here. Okay, I'm gonna use blue color. The 31 is right here, then 32 all the way to 33. So right here, the blue color, what is the concavity?
Down.
Concave down. So I'd like you to write the justification. The function is concave down from 31 to 33. Clear, guys? So the function concave down from the interval 31 to 33. This is how you write the justification. Okay? You don't have to keep doing this way because we only have limited space, right? So just do it this way. So what's the third question, guys? Ezra? What's the third question?
Is there a relative max, relative minimum, or neither at point x equals 82?
X equals 82. Can you continue? Can you continue doing this one? Remember, at x equals 82. Okay? The x right here in the blue color is from 31 to 33. This time, it's going to be 82. Okay. And it says, whether it is relative max or relative mean. Now, look at the question, 82. That means 80 is a multiple of 4, right? So therefore, we can say that 80 is here. Do you get me?
Yes.
So this is 80, this is 81, this is 82. So where do you think is 82? At the bottom, right? This is the 82 right here. Did you get me? On top is 80. If this is 80, this is 81, and this is 82, which is this one. Now, what is 82? Relative max or relative mean? Huh? Tell me honestly. Max or mean? It's mean. Okay? Good job, guys. This is minimum. This is minimum. What about 80? Max or mean?
Max.
Max. How about 84? Max, right? So, can you write now the justification? So, you're gonna have to write at x, or there is a relative minimum at x equals 80. Can you write down the justification? There is a relative minimum at x is equal to 80. Okay. Any question? We now move on to the practice. Okay, so the following graphs show one period of a periodic function. Sketch the rest of the graph on the given axis and answer any questions that follow. What do you think is the period of this? What's the period, guys? The period starts at 2 until where? Eh? The period starts 2 up to where?
3.
So we count from 2. 1, 2, 3, 4, 5, 6, 7, 8. So the period is 8, right? Therefore, if this starts at 2, this is 10. You get me, guys? Because the period is 8. So I'll say 2 to 10. That is one cycle from 2 to 10. Okay, next. What is the question? Is the function increasing, decreasing, or both in the interval from 52 to 56? So what do you think is the next cycle right here? So the next cycle would be 10 to 18, right? 10 to 18. Am I right, guys?
Yes.
Plus 8, plus 8, plus 8.
Yes.
So the next is 18 to 26. And the next is 26 to 34. And then 34 to 42. Then 42 to 50. And then 50 to 58. What is the question? Is the function increasing or decreasing or both on the interval 52? So if this is 50, this is 51, and this is 52. Am I right, guys? That's 52. And then all the way to 56. 54, 52, 53, 54, 55, 56 until here. So what is that? Increasing or decreasing?
Decreasing.
So I need you to write down the justification. The function is decreasing on the interval from 52 to 56. Can you please write down the justification? Do we have enough time? How much time left? In? The bell rings in 10 minutes? 10 minutos? Okay. So is this clear, guys? So I need you to write down the justification. The function is decreasing. From the interval Okay, next question. Question B. Is the function concave up or concave down or both on the interval 30 to 34? Where is 30? What do you think? If this is 26, 27, 28, 29, 30, right here. This is the 30. Concave up or concave down? Look at the blue color. What is the concavity? What is the concavity, guys, on the blue color? Concave up. So I need you to write down the justification. The function is concave up on the interval 30 to 34. Okay, Giovanni.